with all of the different types of elements that we actually get as contamination on our instrument. Think about the softer tissues, think about brain, for example, and bladders. Those are the types of tissues that leave residue on instruments, and that residue is not blood. And this is exactly when we have to think that the test soil should really represent that type of challenge.
Millions of patients undergo surgical procedures every single day. Working behind the scenes are the technicians who go largely unknown, even to the patients whose lives are so dramatically impacted by their work. This is Beyond Clean, the global voice of sterile processing. Join us as we explore this hidden world and introduce you to the unsung heroes driving the advancement of our profession. And now, your hosts, Hank Balch, Justin Poulin, and Michael Matthews. Beyond Clean.
This week on Beyond Clean, we speak with Pawel de Sternberg Stojalowski. Pawel is an R&D engineer with a passion for clever solutions first and foremost. He has a background in mechanical engineering, automation, robotics, and business STEM innovations, and takes an interdisciplinary and cooperative approach to his projects. He has been involved in the R&D of equipment and technologies for the decontamination and sterilization of complex surgical instruments since 2007. Pawel has a focus and drive to impact the global problem of hospital-acquired infections. Today, Pawel leads an expert team researching, designing, prototyping, and evaluating innovative solutions aimed at solving challenges in decontamination of complex surgical instruments, contamination detection and identification, as well as fluid dynamics and ultrasonic waves in washers. This is going to be his second appearance on Beyond Clean, Mike, and I'm looking forward to getting his expert engineering opinion on the show today because he's always got lots of detail and science behind what he shares with our listening audience.
Oh, yeah. One thing we know about Pawel is that he is one of the most process-minded people that you will ever talk to. And so it's going to be really great to get his opinion on one of the more ubiquitous things that we find in sterile processing departments, that being the process challenge devices. You know, there's a lot of them out there, and figuring out what they do specifically and more importantly, what they don't do is going to be a really critical thing that I think that he is uniquely suited to be able to answer.
Looking forward to getting into that with Pawel today. As a reminder, you can subscribe to Beyond Clean on iTunes, Stitcher, Google Play, and Spotify, or search for Beyond Clean on your favorite podcast application. We can also be heard on the Sterile Education app available on iTunes and Android. Don't forget to visit us at the ISHM Annual Conference and Expo. You can find us at booth number 256, and we are hosting our second annual myth-busting panel discussion on Monday night. Register now at beyondclean.net as space is limited. You can follow Beyond Clean on Twitter at BeyondCleanInfo, Facebook.com/BeyondCleanPodcast, LinkedIn.com/company/BeyondClean, and our Instagram is Beyond Clean Podcast. If you have a recommendation for a future guest or topic on the show, you can send us an email to info@beyondclean.net. Season 4 of Beyond Clean is brought to you by Anderson Products and Keys Surgical. Superbugs are evolving quickly. Is your infection control keeping up? Introducing the new FDA-cleared EO Gas 4, combining the proven reliability of ETO sterilization with a new high-efficiency microdose technology. Produces zero emissions to the environment and manufactured here in the U.S. with over 5,000 Anderson sterilization systems in use worldwide. Learn more at anpro.com. That's ANPRO.com. And Key Surgical, a leading provider of sterile processing, endoscopy, operating room, and instrument care supplies, committed to manufacturing and distributing the highest quality products. Key Surgical maintains the highest level of applicable ISO and FDA requirements. Continual dedication to personalized customer service and an extensive product line allow Key Surgical to serve the needs of hospitals, surgical centers, and more throughout the U.S. and internationally. Go to keysurgical.com to find a wide variety of instrument processing and protection solutions, as well as continuing education courses in sterile processing best practices. We'll be right back after a short break. Beyond Clean. Joining us now is Pawel de Sternberg Stojalowski, Managing Director and R&D Engineer and Consultant for Decontamination of Medical Devices at Aseptium. This is Pawel's second appearance on the show, so we've gone back to the well a little bit, and Pawel had an amazing interview in Season 1, and so we're happy to have you back on the show to talk about process challenge devices today.
I'm super delighted to be on the show again. I think this is a great opportunity to share some more knowledge and discuss more interesting topics. I know I was talking about a completely different area before, but now we are actually drilling down into what I do on a day-to-day basis and what we really specialize in. So I'm delighted to be here again. Thank you.
Excellent. Well, why don't we start? I know many of our listeners are very familiar with process challenge devices, but let's define it and set the table for the conversation today. What is a process challenge device?
So the process challenge device is, you really have to think about it as a test device that evaluates the effectiveness of a process. We know very well there are process indicators and process challenge devices that test your sterilization, that test your disinfection, and they all work in different ways. What we'll be probably concentrating on today will be the process challenge devices that evaluate the cleaning processes. So when that challenge device is being developed, we have to think about creating the challenge that is equivalent or greater to the most difficult to process element that is routinely used. So this is the idea that we have a test that is equal or harder to what you normally have during the day.
And so when we talk process, though, I think to Justin's point, when most folks who are familiar with process challenge devices think about the category, the topic, the focus is on the challenge, which, for obvious reasons. But I think as we go in here, we may need to take one step back, even as we're talking about process challenge devices in the cleaning process. What specifically in that cleaning process is being challenged by these?
So for evaluating the cleaning effectiveness of the process, we are looking to mimic real surgical instruments, and especially those that contain difficult to clean features. If you take any of the complex instruments and look at them closely, you'll find out that it's not just flat surface that you need to remove contamination from, but they have crevices, they have joints, they have elements that just simply difficult to access from the outside. And this is what we are really looking for, is we are trying to find out a situation, we are trying to mimic or simulate a case that is difficult to clean. And the process challenge devices, their role is to resemble as much as possible the real difficult to clean instruments, and at the same time be the simple to use tool to actually evaluate how effectively that contamination is removed from them.
So, Pawel, we've talked about many times here how much surgery is changing and at such a rapid pace. What is the current state of process challenge devices when it comes to keeping up with the rapid changes in surgery and the way that the designs of these complex surgical instruments are changing?
So I think that what we have to look at from this perspective is to figure out what makes a good process challenge device and what features would we like to have in that process challenge device that would resemble the sort of modern complex instruments. And the first main distinction is to look at the fact whether we are actually cleaning the instrument pretty much externally with the use of spray arms, or are we actually connecting the instrument physically to the washer and allowing the water to flush through it? Because those are two completely different processes, and this is something that we have to remember, that they are not the same and they have to be evaluated separately. So when you think about process change devices, this is the main sort of focus point, that some of them will only test how effective your spray arms are, but your spray arms do not really clean the instruments inside. For that, we use different processes, and the process change device need to reflect on that situation. The second element is we have to think about what are we actually cleaning. The test soils that we have been developing for process change devices, you see on the market there is a whole range of those, and we have both natural products that based on animal blood. We have products that are fully synthetic, that contain some sort of a substance that is applied to samples that is gradually cleaned, in the process. The major question when it comes to test soils is, what does it actually do? What was it actually calibrated against, and what we are actually looking for in terms of the removal of that substance? Because what we have to remember is that very often we have different washers, we have washers with different types of cleaning chemistries, and we would like our test soil to be as realistic as possible. And I think that one of the major issues that we are having at the moment is that, especially with some of the synthetic test soils, is that they do not really fit in that category, because you have a substance that may be sort of easily removed with one chemical or with one class of chemicals, and not so much with another. But how does it actually represent the real contamination? And when we talk about real contamination, you also have to think about what are we actually using surgical tools for, because a lot of PCDs on the market use blood and blood-related products. But during the surgery, we are not actually operating on blood per se. Blood is just there because it's the fluid that delivers energy to the cells in your body. But we are actually operating on tissues. And it's the tissues with all of the different types of elements that we actually get as contamination on our instruments. Think about the softer tissues. Think about brain, for example. Think about bladders. Those are the types of tissues that leave residue on instruments, and that residue is not blood. And this is exactly when we have to think that the test soil should really represent that type of challenge. The third element, when you are putting together a process change device, is to think what you are actually measuring or what you are actually trying to test for. Because as I mentioned at the beginning, the first distinction is whether you're actually looking at external cleaning with spray arms or internal cleaning, and those are two entirely different processes. But even when you look at cleaning with spray arms, we very often see process change devices like little samples of stainless steel or other materials with a little dot of test soil inoculated on them. And they are just being placed randomly in baskets and put through the washer. Some of them have got holders that you attach to baskets, and we just assume that this is the way to go. But we have to take a step back over here and think, what are we actually evaluating? So a good PCD would look at those features like narrow gaps that you have in box joints or instruments like scissors, clamps, and so on, where you have one element very closely aligned with the other, and there's just a tiny amount of space between them that still needs to be cleaned. We also have to look at how our challenge is representing the cases like shadowing. Shadowing is when one part of instruments actually sits on the other part of an instrument and blocks the access of the sprays to one particular element of an instrument, and that is really also something that we need to factor for. Then the question is, are our instruments three-dimensional or are they just flats? Because if you are only having a tiny strip of metal or plastic, this only represents a flat surface. And we have to look at cleaning not only from the top, but also from the sides and from underneath. So our PCD should factor for that, and we should understand where the limitations of particular solutions that we are using are.
I do have one kind of random question, though, regarding the PCDs that use animal blood. I've been asked this before, and I wasn't really sure how to answer it. Do the PCDs that utilize animal blood as their medium, do they represent a potential cross-contamination risk if they are utilized, or if one that is not completely clean makes it over to the clean side?
Well, what I would look at is the way they are manufactured, because I would assume that as a part of the process, we are eliminating sort of microbial contamination that is on those PCDs. So I would say that if the PCD was developed properly, that risk is minimized to a minimum. On top of that, you also have the cross-species contamination, which is not an easiest thing to do. So the further you are from the human, the harder it is to transmit something.
I'm going to follow up there too, Pawel, and just make a comment on your shadowing point there. That's a topic that comes up obviously as we discuss ultraviolet disinfection, and typically that's in a hospital room setting, but those shadows still cause a problem in that context. And you make a great point, and I've had that question personally as well when I walk in to see facilities doing what should be a challenge in the easiest possible environment of a washer, which is an empty basket with a flat surface with no shadowing, as you said, directly from the top. And then as the actual washer is loaded, then all the complexity comes in. So I think you're making definitely a valid assessment of the true current issues. I did want to follow up, though. You talked about a couple of misconceptions, even with the three-dimensional nature of this concept. Are there any other myths out there that you see either users believing about process challenge devices or even manufacturers of these devices falling into themselves?
Yeah, I think that the main myth about the process challenge devices is that they are all the same, and because this is a cost, you should go for the one that is cheapest. And the problem over here is that when you apply this logic, you'll find out that the process challenge device doesn't really give you the answers you are looking for. It just becomes a pure cost, because if the process challenge device is not allowing you to feel confident with your process and not actually allowing you to maintain the performance level and check this performance level on a daily basis, then whatever you're using is just a waste of money. Because what we have to remember is that the true value of process challenge devices is not when they pass, but it is when they fail and in how they fail. Process challenge devices, as I mentioned, they are a cost. So what we need to do is to maximize the information that we get back as a feedback from using them. And this is only possible when we know exactly what makes our PCD fail. In our case, let's, for example, consider the case of shadowing. If you are not checking for shadowing, then you are tempted to load the machine to the maximum because your PCD is always telling you it's fine. But you'll find out very soon that if you look deeper into details, that this is not necessarily the case. That if you stack instruments on top of each other and you make it really difficult for the washer to perform and access the difficult to clean areas, you'll actually find out that you are getting dirty instruments on the other side, but your indicator still tells you that it's all right. So we have to be absolutely critically looking at process challenge devices and don't only use them as a tick boxing tool, but actually use them as what they were meant to do. Challenge your process. Find out what makes your particular washer fail. Is it the chemical? Is it the way you load it? Is it perhaps the combination of the cycle or the cycle parameters that you have set? Are they really representing the type of instruments that you are washing? So use the PCDs and try to make them fail. That is going to make you understand your processes much better.
I know, Pawel, we've talked about the importance of failure in this category offline a number of times, and I know I can speak as a user, but also as a consultant who's in a number of hospitals around the U.S., and I consistently see an aversion toward failure for these tests. I don't know if it's just a normal assumption that if there is a test, then you want to pass it, which obviously that is the goal, to have equipment that's operating correctly. But on the flip side, as you alluded to, there is a true underappreciation for what a failure in these tests can actually tell you about the true safety of your processes and the health of your equipment. So I would like you to talk a little bit more about category of failure and how to approach that. But also, I want to ask this before I forget, a lot of this goes into training frontline technicians and department leaders in how to think more broadly about a quality program, process management program, because if you don't have that in the background of your mind are we just doing these tests because some regulatory body says that we have to run these tests, or is there a higher purpose here? And if so, what is that purpose? And how do we teach folks in these departments how to approach those tests? So to remind you again, can you speak to the importance of failure again, and then also how we teach leaders how to approach this more from a systematic standpoint?
Certainly. I think that this is a really great question over here because, we meet the same approach over here, but I have to, look at the problem from a slightly different point of view first to explain that. The question is, why would you use a process challenge device at all? Right? Why do you want to spend money to use a device? What do you really need in order to induce confidence in your process? Because this is where the PCDs really come into play. We are looking at tools that make sure that our processes are not only executed correctly, but there is a certain level of quality that we guarantee with the use of those process challenge devices. This is really the critical element over here, that it's not only about making that pass, let's say, once a day. It is about ensuring that we have continuous quality output from your washers, from your washing and cleaning process. Because this is pretty much the last check that you do after releasing instruments further on. So we would like to know that whatever happened before you actually evaluate the load on the clean side actually went through the proper process, that nothing was skipped, that the right detergent was dosed, and you have the right outcome. So process challenge devices are actually more of a quality measurement and monitoring tool than anything else. And the idea over here is to make them as a test, ideally, when you can quantify the result. So ideally, you would like to have a situation where you could give a number or get a number after your process that tells you how well your process is performing. And that is really the whole challenge over here, because, just throwing PCDs that are not giving you any feedback through your washer and being happy that on the other side they come out clean, this is just waste of resources and time. So this is the main reason why we are looking at the use of PCDs at all, is to find out how we can improve the quality output from our washing and cleaning process. And we have to make this distinction over here that only properly cleaned instruments can be safely sterilized. Because if you don't actually perform that cleaning process to a degree that guarantees this sterilization is effective, yet again, all you've created is waste. Because no one is going to stop out of sudden and not put those instruments through. They are going to complete the process, but you will know that after cleaning, it's actually the result is uncertain. So it just becomes a cost.
Pawel, that's great. And I think getting that additional data to just be able to look at trending would be very valuable. And you leaned on this a little bit in your answer to the last question, but this is the final one for the interview. Why does the frequency of testing matter? You said, not just necessarily daily, but should it be weekly, daily? Should it be more often? And what would be the underlying reasoning for that?
So this is yet again coming back to the question of risk, because the frequency is directly reducing that risk. If you are actually looking at implementing those process challenge devices in your daily routine, then at least you know that every day you test whether your washer is performing okay. But think about all of those times when you are changing the chemicals, for example, or using different baskets, or using different instrument carriers altogether, you are changing programs and so on. This is when you have a chance to yet again confirm that everything is working properly. I don't think that the question whether weekly, daily, or more often is easy to answer, because at the end of the day, it reflects on individual sterile services routines, because they know whether they are making mostly the same type of loads in the same type of cycles, or is there a lot of variability in what goes through the department and so on. So I think that if you think about, yet again, coming back to the question of reducing risk and setting up a target, this is going to give you, or this is going to allow you to design your quality management system around the process change devices to give you the required level of assurance that everything what goes through your sterile services from the cleaning point of view is performed properly.
Pawel, another excellent interview. Thank you so much for coming back on. This is obviously an area of expertise for you. I know our listeners will really appreciate it, and a lot of good food for thought. The technology just continues to emerge in this space, and looking forward to just more data to help us all make decisions and evaluate quality. So thank you for coming on the show again.
Absolutely. Thank you very much for having me. I'm happy to take more questions online and offline if there are any. And hopefully we'll be able to still raise the bar in sterile services and improve the handling of risk in what we do on a day-to-day basis. So thank you very much once again.
That was Pawel de Sternberg Stojalowski, Managing Director, R&D Engineer, and Consultant for Decontamination of Medical Devices at Aseptium. And talking about process challenge devices today, Hank, I love the science behind all of it. Like, he didn't even necessarily want to say it needs to be weekly or daily. It's really a lot more about what information you're getting and how effective is your testing and how effective is the equipment.
That's right, Justin. If you were listening closely, some of the things that he discussed as reasons why you would want to retest, for instance, also mirror the same kinds of things when we talk about testing our sterilizer after any big change, different types of load, any repair. The same thing is true on our washers, and yet do we really think in those similar quality management categories? And I think that's one of the challenges coming out of this interview, and challenges was an intentional pun there, but to look and say, are we being as thorough and difficult to pass these tests as we can? And I know one of the exciting things about this interview that we love to do is do giveaways, and as a part of this particular content, we'll be giving away 5 of the new and improved process challenge devices that Pawel and his team have been working on, just to get a couple of those out in the industry so folks can see a little bit more in real life what these types of next generation devices actually look at. So stay tuned on the website and the mailing list for more information about how to win a package of one of those.
All right, that's going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes or Stitcher and Google Play and Spotify. Simply search for Beyond Clean Podcast. We'd appreciate a rating and a review because your feedback is important to the show. And if you have any topics that you'd like us to cover on a future episode, or if you'd like to share a picture anonymously on our Instagram page, just send an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.